Hi, let me tell you about another great Manning book, 100 Java Mistakes and How to Avoid Them, written by Tagir Valeyev.
Improving code quality is essential to prevent bugs, which can range from minor to catastrophic. This book tackles common, subtle Java programming mistakes that can cause bugs. It provides examples, explains causes, and offers strategies to avoid them. Unlike compilation errors, these mistakes can slip by unnoticed. The book also covers broader code quality techniques like static analysis, defensive programming, and testing. Java allows various coding styles, and while some choices are personal preferences, others can reduce bugs. For example, using 10L uppercase instead of a 10L lowercase for long type declaration avoids confusion, as lowercase l looks similar to digit 1. Consistent code style can enhance readability and reduce errors, but it's not a complete solution. The Google Java Style Guide and IDEs like Eclipse and IntelliJ IDEA can help enforce code styles. Static analysis, or linting, is like an automated code review that highlights potential issues. There are many static analysis tools for Java, such as IntelliJ IDEA, SonarLint, and ErrorProne. These can be integrated into IDEs or the build process. While static analysis is helpful, it has limitations and should be complemented with other techniques, such as human code reviews and automated testing. Automated testing is essential for finding bugs. Tools like Jacoco help with measuring test quality through code coverage. However, high coverage doesn't ensure bug-free code, and tests can have bugs themselves, highlighting the limitations of automated testing. Some projects may benefit from property-based testing using frameworks like JQuick. Mutation coverage assesses test effectiveness by introducing small changes to the code and checking if tests detect them. Tools like PyTest automate mutation testing. Mutation coverage can be slow and complex, and some mutations may not affect testable behavior. It's recommended to achieve high-line coverage before using mutation coverage. Dynamic analysis finds bugs during code execution, complementing static analysis. Tools like Java Pathfinder and DLCheck can identify concurrency issues, but are limited to the code that is run. Dynamic analysis relies on test coverage to find problems, while static analysis can find bugs throughout the codebase. Adding code assertions directly into production code is a technique similar to unit testing. Assertions help identify bugs early by asserting the expected state of your program and failing immediately if the state is unexpected. This makes debugging easier by pinpointing issues close to the actual bug. Without assertions, incorrect states might go unnoticed for longer periods. Individual bug patterns, described in the following chapters, will help you recognize and avoid them early.
Get this book at Manning.com